everyone, my name is Maureen Shane El Serapio from BSME 3D. So for today's video, this is the continuation of the previous topic na diniscuss natin last week. So, ang topic na didiscuss natin ngayon is all about the AC and DC generator, the components, the differences between the two, the similarities, and advantages. Alam naman natin, ang DC generator ay gumagamit ng electromagnetic conduction to convert mechanical energy to electrical energy. Ito ay madalas ginagamit sa house and offices. Pero alam ba natin how it is constructed? So let us try to understand this. DC generator consists of magnetic frame of yoke, the pole core, field coils, armature core, armature windings, commutator, brushes, and the bearings. Are these parts the pole core, the armature core, the yoke, and the air gap between the poles and the armature core form a magnetic circuit? Let's start with the yoke. It is the outer frame of a DC generator at ito ay mayroon dalawang purpose. It acts as a cover or protecting shield for a generator. Also, it provides mechanical support for the poles. In small generator, yoke are made up of cast iron. Cast iron is cheaper in cost but heavier than steel. But in large generator, where weight of a machine is concerned, lighter cast steel or rolled steel is preferable for constructing yoke of DC generator. Field magnet. It consists of pole core and pole shoes and field or exciting coils. It produces or spread out the main magnetic flux in the air gap. Due to its large cross-section, it reduces reluctance of magnetic path. Also, it acts as supporting coil. Pole coils consist of copper wire wounded informer. Pagkatapos makuha yung current dimension, yung former is removed. At ang round coil is put into the place or core. When current is passed through these coils, yung poles naman ay makakakuha ng electromagnetize and produce necessary flux. Armature core, it houses the armature conductors of coils and causes them to rotate armature cut the magnetic field dahil sa EMF is induced in it. It provides a path of very low reluctance to the flux through the armature. It is cylindrical shape or drum shape. It is generally built up of circular sheet steel disc or lamination with stamping about 0.3 to 0.5 mm thickness. Armature windings. There are two types. Lap windings and wave windings. So, ang pinagkaiba nilang dalawa ay dahil sa arrangement ng connections on the front of commutator of the armature. Commutator. It facilitates the collection of current from the armature conductors. It converts alternating current and used in armature conductor into unidirectional current in the external load circuit. It is cylindrical structure and is built up of wedge-shaped segments of high conductivity hadron or drop force copper. Brushes. They collect current from the commutator. They are usually made up of carbon or graphite and are in the shape of rectangular block. They are housed in the brush holder, which is mounted on the spindle. These brushes can slide in a rectangular box, which is open at both ends. A flexible pigtail is mounted at the top of the brush, conveys current from brushes to the holder. Bearings. They are frequently employed because of their reliability. Ball and rollers are generally packed in hard oil to require an operations. AC generator. It converts mechanical energy to electrical energy in the form of EMF or alternating current. The parts of an AC generator. An AC generator has an armature A, B, C, and D. It is a rectangular coil with many turns worked around in soft coil. A shaft. It can be rotated rapidly. Field magnet. It is maybe strong permanent magnet with concave poles. There are two slip rings, S1 and S2. Ito ay nakakonect sa armature and rotate with it. Two brushes, B1 and B2. Sila ay nagpo-provide ng electrical contact sa slip rings and load, which may be galvanometer na ipinapakita sa video. Working of AC generator. Kapag yung armature nag-rotate sa pagitan ng field magnet, the magnetic flux linked with the armature changes continuously. As a result, the EMF induced in the armature produces an electric current to the armature and the galvanometer and to the split rings and the brushes. Ang galvanometer needle ay nagsuswing sa negative at positive values, which means alternating current is flowing through galvanometer.
Initially, the armature ABCD is vertical with its arm AB up and CD down. The direction of magnetic field is from left to right. As the armature undergoes a half rotation clockwise, arm AB moves down while arm CD moves up. According to Fleming's right-hand rule, the current will flow in the direction DCBA. So, the current will flow from B1 to B2 through the galvanometer. Now during the next half rotation, arm AB moves up while arm CD moves down. Again by Fleming's right-hand rule, current will flow in the direction ABCD, that is, from B2 to B1 through the galvanometer. Thus, the induced current changes its direction every half rotation. Graphical representation of induced EMF. Suppose the armature takes t seconds to complete one rotation clockwise.
What are the differences of AC and DC generator? AC and DC generators are both use electromagnetic induction para makapag-generate ng electricity. However, yung process ng paggamit nila is magkaiba. Dahil ang AC generator nagki-create ng alternating current that periodically reverse direction. Pero yung DC generator, yung direct current flows niya is in one direction. So, sa AC generator, yung coil which current flow is fixed and the magnet usually moves. The south and the north pole of the magnet make the current flow in opposite direction, which means magkakapag-create siya ng alternating current. Sa DC generator is not fixed, rather it rotates in a fixed field. Yung two ends of coil are naka-attach sa commutator na kung saan para mabalanse yung mga charges from the generator. Na kung saan ito ay magre-resulting in a current does not alter direction. The similarities between AC and DC generators. AC generator and DC generators are that both work on the relative motion of a coil between the coil of the wire and the magnetic field which is used in the productive of electricity. Since meron tayong generator which serves a different purpose, there are several advantages to each. So, let's start with AC generator. Cost-effective, perfect for small and electrical appliances in the office. Lower maintenance needs. In DC generator, simple design, runs large motors, and smooth voltage. And that's all for today. Thank you for listening. Keep safe and God bless.